Hi guys, my name is Gopal and today I'll be talking about how to draw an SN curve. So what is an SN curve? An SN curve is a graph that shows the correlation between fatigue strength, which is here, which is S, and the life, which is N, which is measured in cycles. The vertical axis of the graph is S and the horizontal axis is the life. An SN curve is drawn by inputting the fatigue strength value onto the y-axis at 10 to the power 3 life cycles, and the life cycles value on the x-axis at usually 10 to the power 6 cycles. So say this is our point for our fatigue strength here, and say this is the point for our life. What we do is connect a diagonal line from there to there, and then we'd have a horizontal line going beyond that. And that's how we would draw a SN curve. Now, how would you use charts and tables to figure out the coefficients? In order to draw an SN curve, the variables Sn and Sf would need to be found. This is done by utilizing the table at the top here, the graph here, as well as this table here, as well as the information that is given from the question. In this table here, we're given various materials with their corresponding Su and Sy values. And we're also given the hardness and the tensile strength in the axes. So this is tensile strength here and the hardness there. And also each curve here represents the material finish. In this table here, we are given the information about the loads and what corresponding values are available based on the situations that we're given. These values will be used for the formulas here that are listed here to find the coefficients. Once all the values of the table are found using the table here, as well as the table in the graph mentioned earlier, they can be substituted into the formulas that we set here, which will yield the coefficients needed. How would we use the SN curve to find the fatigue strength at a certain number of cycles? The fatigue strength can be found by drawing a line that is vertical from the number of cycles given to the SN curve, and then a horizontal line from that point where contact is made to the y-axis. The corresponding point on the y-axis is the fatigue strength. So if we were given, say, 10 to the power 5 as the life cycles, we draw a vertical line from there to the SN curve, and from that point where the line meets the SN curve, we draw a line that goes horizontal towards the y-axis and meets there, and that point there would be 75 KSI, which would be our strength. Using the same logic, we can find the fatigue strength at a given number of cycles. The horizontal line is drawn from the fatigue strength until contact is made on the SN curve, and then a vertical line is made to the x-axis from that point onwards. Once the x-axis is reached, the value on the x-axis is the number of cycles for the certain applied stress. So say the value we're given is 92 KSI. We draw a line from 92 towards the SN curve, and from that point we'd start drawing a line that goes vertically to the x-axis, and 10 to the power 4 cycles is the life value. Alright, let's do an example. In this example, it says estimate the SN curve showing bending load of machined steel specimen having the SU value of 200 KSI and the SY value of 150 KSI. The diameter is 1 inch. It says to also find the number of cycles at 60 KSI and the stress at 3 times 10 to the power 4 cycles. So first we start off by listing our given. And our given would be the SU value of 200 KSI, the SY value of 150 KSI, the diameter, which would be 1 inch, and we know that it's machine surface, and we also know that we need to find the bending load. So first we start off with getting SF value, which would be 0.75 times the SU value times CT, which we'd get from one of the earlier tables that was shown. So 0.75 times 200 is our SU value, sorry. And if we go up to the this graph here, We start off at 200 KSI. We go up towards the machine, and we'd go towards the y-axis here, which gives us around roughly a value about 0.62 being the value of CT. So 0.62, which would equal 93. Next, we'd find our Sn prime value, which is 0.5 SU, which is 0.5 200 times 200 equals 100. And then we'd find Sn. And since we're trying to find bending, we'd go up to this here, and we'd use this formula here. So Sn equals Sn prime times Cl times Cg times Cs times Ct times Cr. And then we'd fill in the coefficients. So Sn prime is 100 times the Cl, which is 1.0 for bending. 1.0 times Cg. Since our diameter is above 0.4 inches, but below 2 inches, we'd put 0.9. So times 0.9. And then Cs would be what we've calculated earlier, which is 0.62. 0.62 times Ct, which is 1.0, as we're using standard temperature. And then a reliability factor, again, standard is 50%, so that'd be 1.0. Our value here would equal 55.8 KSI, sorry, 0.0. And we can use that value for our table, or our Sn curve graph below. So we have the Sn value of 55.8 KSI and our SF value of 93. So we start off by labeling our graph here. Start off with 10 to the power 3, go to 10 to the power 4, 10 5, 10 6, 10 7. We start off here on the y-axis 1, 10, 100, and 1000. Beyond that, it's not usually necessary. So we put our Sn on the x-axis here, go up from 10 to the power 6 up to 55, which is about there, and then our 93, which should go on the y-axis here, about there, and we connect these 2 points using a line, and then we go beyond by using a horizontal line, and that would be our Sn curve there for this. But we also have 2 other things we need to find, which is the number of cycles at 60 KSI and the stress at 3 times 10 to the power 4 cycles. So to find these values out, we'd make a line going from the y-axis here, from 60, we'd go from there to the point that matches on our Sn curve, which is about there. And then we make another line going down. Okay, we know what it is. This is 10 to the power 5. 1 times 10 to the power 5 cycles. So that would equal 10 to the power 5 cycles. And to find 3 times 10 to the power 4 cycles, we start off at 3 times 10 to the power 4, which is here. Go up to the Sn curve, and then we make a horizontal line from that point onwards to about there, which we can say is 68, around 68 KSI. That's how you draw an Sn curve, find the coefficients, and use the Sn curve to find the number of cycles or the stress. Thank you for listening.